Welcome back. We're in the home stretch of EE Times live coverage of the 2011 Design Con from the Santa Clara Convention Center. I'm Brian Fuller, editorial director of EE Times' EE Life community. And with me is DOrrechio, CEO of DOrrechio. And Dave is sort of, well, number one, he got out here without getting trapped in any sort of bad weather. I don't think he'll ever get home. Number two, he's sort of torn. You can't quite see it, but he wears a black armband because his beloved Patriots just got slapped out of the playoffs like what's nobody's business.
What's worse, it was by the Jets. You know, it couldn't have been a worse foe. But you know, I won't hold that against them. There's always next year. That's what we're here to tell. And you're right about the weather back in Boston for the double E's that are working either from home or from their office. I understand they're building igloos in Boston. I mean, the snow is like this, and they're getting another foot. So it's going to be quite the mess. So who knows when I will get home. Except the weather's here is fantastic.
Yeah, the weather's going to be great.
And thank you so much for doing these interviews. It's very interesting.
Yeah, so let's start off by just tell us a little bit about DOrrechio. I know some people know about it, but it never hurts to kind of spread the word.
Absolutely. So basically what DOrrechio is DOrrechio's a company that's totally focused on FPGA verification and debug. And our product is called a Rocket Drive, and it integrates with the simulators from Cadence, Mentor, and Synopsys for the purposes of accelerating verification and also enhancing debug. It's one of the biggest problems as these chips become large is the fact that it's very difficult for the engineers to really find the problems associated deep inside the chip, because the tools that were developed for FPGAs back when they were small are no longer doing the job. And that's, in fact, one of the key reasons for the panel that's this afternoon is about tools keeping pace with the trends of the actual FPGA devices themselves.
Yeah, so we'll talk about that panel in a second because it has a very sort of clever title. But you guys, as part of DesignCon, won one of the Design Vision Awards for Soft Patch.
Exactly. Yeah. So basically, the product, like I said, it's in two pieces. It's the hardware itself and the software that works with the hardware in conjunction with the simulators. Soft Patch is an innovative capability and a good analogy for what Soft Patch basically does. It's kind of like an in-circuit emulator for FPGAs. Because what it does is it gives the engineer the ability to take a block that's running inside the hardware, inside the FPGA that's inside the Rocket Drive, and while they're working in their simulation environment with all their tests, their test bench, and all the tools associated with it, and move blocks at their whim between the hardware and the software. So as part of the debug process, when you find a bug that's inside the FPGA, how do you test it? How do you fix it and test that your fix actually works? You use Soft Patch. You literally take that block, which is a hard block, move it back into the simulator. It's now soft, and the engineer can make changes to it until he's got it fixed. And that's one of the reasons why we won that award.
Very cool. And you have a conflict this afternoon. We're giving away these awards. I mentioned it before, but we're giving them away at, I think, around 5 o'clock or 4:45 in the Chiphead Theater on the floor. You have your Patriot support group meeting, and so you can't go. But we thought that we would sort of give you this sort of Oscar-looking statuette, just so you can kind of have that experience, because you won't be there to actually get the real hardware.
I thank you guys, and I thank the Academy for everything they've done for us. So, and anyways, the product speaks for itself. Customers love the capability, and I think that's really the best award we could ever get.
So when you guys win something like this, do you give the engineering team an all-expenses paid trip to Hawaii or Jamaica?
Well, that's in the plans. You know, once we reach $1 billion in revenue, that's the internal target.
So this will be archived, and for you DOrrechio guys, you might want to just bookmark that.
Exactly.
So. Let's jump up a level and talk a little bit more about trends you're seeing in FPGAs, because as system on chip becomes more and more difficult, becomes more and more expensive, you know, you're seeing $100 million projects just to get started. So design starts are shrinking by the second.
Exactly.
FPGAs are even with their die size issues and all that kind of stuff, are sort of becoming the approach of choice. So talk a little bit about the trends there.
Exactly. So, and yeah, that's the thing that's really exciting about Gate Rocket and the industry that we're in right now. The FPGA vendors are doing a wonderful thing for the industry. They're capturing the latest geometries and delivering them to the masses. So, in the old days, if you needed to get access to the deep submicron technology, you needed to go and fab a device. Nowadays, you can get the benefit of the latest technology node on your desk. Engineers can program it on their desktop. But if you look at what the trends are, what's happening, I think back to the old days where the structured ASICs were really taking off, right? If you think about what happened then, basically a number of vendors were basically taking ASIC technology and wrapping hard cores in the outside, right, to deal with SerDes, communications protocols like Ethernet Max, and other technologies like that. If you look at today's FPGAs, that's exactly what the FPGA vendors have done. But instead of the the programmable layer being a metal layer or whatever, it's the FPGA itself. So what I see happening, the trends are that all of these very complex cores are being baked hard inside of the FPGAs with a significant increase in the free logic for the engineer to program. So if you, for example, if you look at the last two technology nodes, the number of LUTs that were available for engineers to use doubled with each node, and they're doubling yet again at the 28 nanometer node. You'll be able to program 1 million LUTs in a single chip. That's unbelievable density. And the complexity of these chips is more than just, it's not like a linear increase in complexity, it's exponential, because on top of that you have those hard cores. So the complexity of designing these devices is just gone through the roof. So that's the fundamental problem as it relates to tools. But if you look at the core resource, the technology that's there, your point about the fact that design starts for ASICs are dropping and that the starts for FPGAs are increasing, you have to have a capable FPGA to be able to take the socket.
Right.
It's got to decrease power, it's got to have higher performance, and the lower silicon geometries are basically allowing the FPGAs to take more and more a larger and larger amount of the available space of the markets. So that's been pretty exciting. So that's on the vendor side and the silicon side. If I look at the customer side, what we're seeing is customers are moving from using FPGAs as interface electronics to the FPGAs becoming the core of the system. And as a result, you've got issues like team-based design. You've got segments of the blocks that come from multiple groups. They try to integrate it together on the FPGA. And communication is one of the biggest problems in team-based design. Interfaces get wrong. And the problem with FPGAs is exacerbated because the process of mapping it into the device is believed to be a push-button process, but problems occur downstream as a result of the fact that this technology is changing so quickly. So people find themselves in a lab with designs that don't work and inability to debug them.
Challenges indeed.
Yeah, absolutely.
And I guess you guys are going to talk about that this afternoon around 4-ish.
Yes,
FPGA
exactly. Caveman
meets FPGA Chiphead. If you're around, check it out. It's here at the Santa Clara Convention Center. DOrrechio, CEO of Gate Rocket, thank you so much for spending time with us. Good luck on the panel.
Great. Thank you.
Congratulations on the award.
Thank you.
Better luck next time in the AFC playoffs.
Absolutely. I think we'll win next year.
Well, I think you've won enough. It's time to bring those 49ers back.
Thank you, and thank you to everybody here watching the broadcast.
Yep. So we're going to take a very quick break because I think we are now teutonically back on time, believe it or not. So we're going to take about a 2-minute break. We'll be back with our next guest, Steve the Man Liebson. I was trying to rhyme something with Steve that wasn't obscene, and I couldn't come up with it. So we'll be right back.
Thank you.